Okay, today we're looking at minima and maxima problems, in particular in mechanics cases, as opposed to just in pure questions, aimed at year 12, this one. Okay, so here we have a displacement time graph. So we've got displacement up on the vertical axis, time on the horizontal axis, and we have 2 points here which we would refer to as a minimum or a maximum. So this one here is what we would call a local minimum. And this point here is what we would call a local maximum. It's a local minimum because if you're at this point and you move either side to the left or to the right, then you're going to go up the curve. So it's a minimum. And at this point here, again, if you start at this point but move left or right, then you'll go down. Therefore, it's a local maximum. And we call it a local maximum because, for example, there are points over here which are higher. So it's not a maximum, it's just a maximum in its locality. Okay, but that's more of a pure thing. So if you want to delve into that a bit further, then check out some pure videos on turning points. Okay, so applying that now to mechanics then, well at this point, ds by dt will equal 0. Just like if we had y as a function of x on a curve, and we wanted to find the turning points, then we would differentiate the vertical variable y with respect to the horizontal variable x. In this case, it's differentiating s with respect to t, and we set that to be 0. And that will give us the coordinate of these 2 points. So we've got one local maximum there and one local minimum here, and there may be others in the curve as well, but we're just given this snippet. We don't know what this function is. This is s is some function of time. It could be anything. Okay. Just want to also draw your attention to one other thing that can come up. Just be careful with what variable you've got on the axes. So here we've got an s against time, but you could be given a graph that's v against time. The turning points on these would mean different things. So a turning point here would be ds by dt is equal to 0. But we know from the previous video that that means v is equal to 0 because ds by dt is equal to v. But a turning point on a velocity time graph here, v is not 0, v is something positive, so it's very much in motion at this point. Here v is 0, okay, and that's not a turning point. So just make sure that you are aware of what's on your axes. Okay, velocity time graphs are different to displacement time graphs. Okay, today we're focusing in particular on displacement time graphs. Okay, let's have a look at an example. A particle P moves in a straight line such that its distance s meters from a fixed point O at time t is given by this cubic equation. And we're also told that t will lie between 0 and 10. First question, initially, how far is P from O? Well, whenever you see the word initial, or initially, or initial conditions, or anything like that, you should immediately think t is equal to 0. That's what initial means. It's the beginning of the model, which is denoted as t is 0. So to answer part A, what we're going to do is we're going to say, well, what is the value of s when t is equal to 0? And that is going to be 82. 0 cubed is 0, 0 squared is 0, 0 is 0. So everything disappeared except for the 82. So therefore, it's initially 82 meters from O. Part B. At what time is the particle at instantaneous rest? This is not something that we've yet talked about. Instantaneous rest is when it is at rest at an instant, as opposed to at rest. So when something's at rest, the velocity is 0. But instantaneous rest is when the velocity is 0 when it's otherwise in motion. Okay, it's at rest for an infinitesimally small amount of time. Okay, graphically, it's the turning point of the displacement time graph. So the link you need to make here is that when a question is asking for instantaneous rest, it means v is equal to 0. That's what it means. V is equal to 0. So I'm going to take my definition of s, which is given in the question, and I'm going to find v, which is, by definition, the differential of s with respect to time. So that's going to be 0.6 t squared minus 11.4 t plus 28.8. and I want instantaneous rest, so that means that I want the velocity to be 0. So I've now got a quadratic equation in t to solve. So a number of methods you can use to solve it. I'm going to use a quadratic formula. So t is going to be minus b plus or minus the square root of b squared minus 4ac. And that's going to be all divided by 2a. So I'll get my calculator. Okay. And I'm going to have 11.4 plus the square root of 11.4 squared minus 4 times 0.6 times 28.8. Oops, this would be a times, not divide. There you go. And that's all divided by 1.2. And that gives me t is 16. And then if I put in the negative root as well, that'll give me my other turning point, which is 3. But, according to the model, t lies between 0 and 10. So therefore t is 16 is not a solution to this. So therefore t is equal to 3. That's my answer. Okay. Now what time is a particle at instantaneous rest? The only time it's at instantaneous rest is when t is 3. Okay, and finally part C, how far does P get from O? What's the furthest that this particle will get from this fixed point? So what I'm going to do here to solve this is I'm going to draw the graph of S again, T against S. But in order to do that, I need to know if this point is a minimum or a maximum. So I'm going to find d2s by dt squared. And that's just the differential of this with respect to t. So that's going to be 1.2t minus 11.4. And I'm going to find this value when t is 3. So this implies d2s by dt squared. If I plug in 3 into there, I'm going to get 3.6 minus 11.4. I don't really care what that is. The fact is that it's negative is enough. Therefore, this is a local maximum. Okay, if the second derivative is negative at a stationary point, then it's a local maximum. Check out some pure videos for more details on that. I also know that it goes through 0 on my vertical axis. I can also work out the value of s when t is 3, and I can work out the value of s when t is 10, because those two are key points. So t equals 3 implies s equals, and again I'm going to come back to my calculator, and I'm just going to plug in 3 into the original equation. That's going to be 3 answer cubed minus 5.7 answer squared. Just make sure you're not plugging it into the derivative. You're actually plugging it into s, not s prime. Easy mistake to make. Plus 82. That gives me 122.5. So that gives me the coordinate of my maximum point. And also t is 10, which is the end of the model. That'll be quite useful. If I plug in t is 10 into here, I'll get 0.2 times 10 cubed minus 5.7 times 10 squared plus 28.8 times 10 plus 82. And that comes out as 0. Okay, so it actually crosses my t-axis at that point. That's enough information now to sketch the curve. Do something like that. There's my t-axis, there's my s-axis, 82 on my s, 10 there on my t, and I can see that this is indeed the maximum point, the furthest it gets from O is 122.5. So my answer then is 122.5 meters, and that occurs when time is 3. Okay, thank you for watching. Hopefully you found that useful.